Kia ora, Year 12. I thought that I'd videoed this question ages ago, but it turns out that I haven't. So it's the one we did during today's online scholarship calc session, and it's the one where we have to find the arc length. But I've managed to do some cool GeoGebra to show you a bit better what's going on with this question. So we're given a differentiable function between 2 points, and we're told the formula for this. And the formula for this is given by this formula here, right? And this is the function we're working with. Y is equal to k minus x to the power of 3 over 2. And this function forms a curve between the y-axis and the x-axis. K, x, and y are positive. We have to figure out what value of k will make the arc length of this curve exactly equal to 56 over 27. So when I did it online, I just gave you this idea by drawing, a wiggly line. And we have to get that length to this number here. And we saw that we need to know these 2 points. But if you look at the function itself with a slider on it, I think you get an even better sense of what's going on here. So you can see here that I've got the curve drawn for different values of k, right? So this one up here, which is the top one, the green one, is when k is 6. The blue one, the function g, is when k is 4. And when we put that slider on, we can see that the value is shifting just between 0 and 10. So what we're looking for is the length of that line enclosed by the 2 axes needs to be 56 over 27, right? So let's go back to OneNote now and work through the problem. So the first thing that we need to do is to figure out what this x value is here, right? We know that up here, x is equal to 0, right? But in my integral, we need to have these 2 limits. So we've got the bottom one, and now we need to find the top one. So at this point here, the value of the function is 0. So we're going to start off by saying y is equal to k minus x to the 3 over 2. And setting that equal to 0 gives us what? Well, we get k is equal to x to the 3 over 2, which means that x must equal k to the power of 2/3. So that's going to be my upper limit. Okay, now let's work with the function and see what we've got. We've got y equals k minus x to the 3 over 2, and you can see we need to differentiate it, square it, add 1, and then take the square root. So doing each of those steps, first of all, we get dy by dx is equal to negative 3 over 2 times x to the 1/2. Squaring that is pretty straightforward. We get 9 over 4x. And then we can add 1 to it, but I'll do that inside the integral because it's not too bad. So what have I got here? Well, I've got the integral from k to the 2/3 down to 0 of the square root of 1 plus 9 over 4x dx, and all of that has to equal 56 over 27. Remember, we're solving for the value of k. So let's take that surd and turn that into a fractional power, and then we'll see if we've got a horrible integral or a not too bad one. And you should see by looking that this is pretty much back to a level 3 question. We've got something to the power of 1/2, and the function inside is not going to cause me chain rule problems because the derivative of the inside function is just a constant. It's 9 over 4. So integrating, I'm going to leave a bit of a gap. We'll have something 1 plus 9 over 4x to the power of 3 over 2, right? Increasing the power by 1. When I differentiate, this is going to give me a 3 over 2. So I undo that with the reciprocal. Similarly, when I differentiate the inside function in my head, I'm going to get 9 over 4. So we undo the 9 over 4 with 4 9s. And then we need to substitute in our limits here, and that equals 56 over 27. So pulling the constant through gives us 8/27 times this equals 56 over 27. I can clean up the constants on both sides. I think Obviously, some of you are probably going, why is she doing every step like this so slowly? There's two reasons for that. The first is that I'm making this video for a wide range of people watching. The second reason is you're less likely to make mistakes when you take each step slowly. But some of you are probably going, oh, we could have substituted the limits in here and done this cleanup at the same time. And I think that's fine. So we get to this, and now we start to substitute. So we've got 1 plus 9 over 4 k to the 2/3 to the power of 3 over 2 minus 1 for this to the power of 3 over 2 equals 7. 1 plus 9 over 4 k to the 2/3 to the 3 over 2 is equal to 8, adding 1 to both sides. Now we're going to slowly undo. We get 1 plus 9 over 4 k to the 2/3 is equal to 8 to the power of 2/3. Now 8 to the power of 2/3 is just the cube root of 8, 2 squared. So that's 4. So 9 over 4 times k to the 2/3 is 3. K to the 2/3 is equal to 12 over 9, just dividing both sides by 9/4, which is equal to 4 over 3. So finally, at last, we get this. K is equal to 4/3 to the power of 3 over 2. But that looks really ugly, so let's clean that up. So the denominator, 3 to the power of 3 over 2, we can write as 3 root 3. And the numerator we can write as, so 4 to the power of square root of 4 is 2. 2 cubed is 8. So that's one final answer. If you want to rationalise the surd, you can write that as 8 root 3 over 9. So there you go. Not too bad a question. Most of that last bit is level 2 algebra, just, you know, in a yuckier context. So if you've got any questions on that one, just send me an email. Thanks for watching.